Good morning friends, today we'll see about the instantaneous center method to find out the velocity in the given mechanism. Consider this, you have the slider crank chain. This is your slider crank chain in which you have link AB, BC and the fixed link A and the slider which is over here with a common point of C. Now, if the proper dimensioning of this mechanism is given, let us say this is 200, the distance is given as 300. Okay, so this suggests that we can reproduce the diagram. All right, we can let us say this is here 400. Okay, so we can reproduce this diagram, right? And it is given that the crank is rotating in clockwise direction with angular velocity omega, right? Now the usual method suggests to calculate all the instantaneous centers and name them. Let's I1, 2, 2, 3, 3, 4, and then find out the velocities of the slider. But instead of going through that, we can also use some logic to find out the velocity, the instantaneous centers directly, and find out the velocity of C of the slider. For instance, in this case, consider that since this link AB is rotating with respect to link A, hence the direction of the velocity of B will be perpendicular to AB, right? Similarly, the slider is sliding in a horizontal direction with respect to the fixed link, hence the direction of the velocity of C will be over here. This is velocity of B, right? With respect to A, with respect to fixed link, that is important. Hence, if I draw the perpendicular from here like this and from here like this is perpendicular, this is also perpendicular, so it will meet at one point which is nothing but the instantaneous center of link BC. It is an instantaneous center of link BC. Why? Because we know that the instantaneous center is a point from which the object is in pure rotation. The object is in pure rotation with respect to the fixed link, with respect to this instantaneous center. Yes, of course, whenever you are considering the velocities, let us say this, I am considering the velocity of this point C, it has to be considered with respect to the fixed link. Here also velocity of B is considered with respect to fixed link. Hence this is an instantaneous center. We already know the velocity of B, which is omega into AB, right? Therefore velocity of B with respect to A and divided by BIBC is equal to velocity of C with respect to A divided by CIBC. Here VBA is known. This can be calculated from the diagram itself. CIBC can also be calculated from the diagram itself. Hence VCA can be known easily. Therefore VCA is equal to VBA divided by BIBC into CIBC, isn't it? So hence we can find out the velocity of point C. Let us say that there is one point E onto this link BC and we have to find out the velocity of point E as well. So this will be nothing but the line joining this point, and it will be perpendicular to this in this direction, such that velocity of E with respect to A divided by EIBC is equal to velocity of B with respect to A divided by BIBC. Hence we can easily find out the velocity of E with respect to A. Now to generalize this, let us consider an example in which we have more than 4 links. This is the mechanism in which we are having more than 4 links. So yeah, yes, this is okay. So here this is your link 1, this is point A, this is B, this is your link 2. This entire BC is your link 3. This is your link 3. This is point D, and this is point E, which is your link 4. This is your 5 and 6. The slider 1 is 5 and slider 2 is link 6. Let us say this angle is given, the rotation of this link is also given. Now we have to find out the velocity of the slider E and slider C using the instantaneous center method. Right? Using the instantaneous center method, we have to find out the velocities of RAM C and D. Sorry, C and E. So we know that since it is rotating in a clockwise direction and it can only revolute with respect to this fixed link, that point B, that means velocity of B will be perpendicular. Velocity of B with respect to A will be perpendicular in this direction. Similarly, velocity of C with respect to point A will be in horizontal direction because A is a fixed frame of reference. So C with respect to E will be in the horizontal direction. So if we draw the perpendiculars onto this, we get one point over here which can be called as instantaneous center of BC. Since the velocities are perpendicular to this direction, that means that link BC will only revolute or rotate with respect to this fixed center IBC. Hence, velocity of B with respect to A divided by IBC into B, BIBC actually is equal to this distance is equal to velocity of C with respect to A divided by CICA. Also, from here itself, since point D is also on the same link, we can also write that velocity of D with respect to A divided by DIBC. This should be BC. Okay. Right? So since we know these two values, we can easily, and this value as well as this value is known to us, this and this can be calculated. So you get some value VCA as well as you also get the value VDA. Now we know the direction of velocity of D with respect to A is in this direction, somewhat like this, which is perpendicular over here, and we also know that the slider E is also rotating in a moving in a horizontal direction with respect to fixed link. This is also with respect to fixed link. This is also with respect to fixed link. Hence, if I draw a perpendicular like this, it will meet over here, which can be called as instantaneous center of DE, such that velocity of D with respect to A divided by IDE, actually DIDE, is equal to velocity of E with respect to A divided by EIDE. Hence, you can easily calculate the velocity of point E.